The diagram shows rectangles ABCD and GFED. ABCD has an area of 44 centimeters squared. GFED has sides 4 centimeters and 2 centimeters. AG is equal to EC is equal to 3x centimeters. Calculate to 3 decimal places the value of x. Now, we arrived at our equation by which we will find the value of x. The equation is x squared plus 2x minus 4 is equal to 0. In this event, all we need to do is solve that equation in order to find the value of x. To 3 decimal places. The value of x is required to be calculated to 3 decimal places. Because the value of x to be found is not exact. Not only that, we are required to find its value to 3 decimal places. We imagine that it will be irrational. Irrational meaning that we will have an indefinite square root in this particular case. An indefinite square root or an indefinite root is the most common irrational numbers that we generally use in mathematics. But they are not the only irrational numbers. We also know that pi, which is approximated to 22 over 7 or 22 divided by 7, also to 3.14, is also an irrational number. Because of the prospects of being irrational, we will opt to use the quadratic formula in solving the equation rather than factorization. So let us go straight ahead in applying the quadratic formula. We begin with your template, and your template will be completed eventually by the numbers that we have for the coefficients of x squared, of x, and of course, no doubt, the constant value that we have there. Your quadratic formula is on your examination booklet. It is in your instructional booklet. It is in your tutorial books, and it is in your paper 2 solution books. And here we have your quadratic formula, the one by which we may use to find the value of x or to solve a quadratic equation. What will be the value of b, a, and c? Or we may say a, b, and c. What will be those values? Now, what do they represent? The values of a, b, and c represent the coefficients to be used. And we will have them alternating in this expression in a short while, so we will not be left with any doubt as to which is which. The values of a, b, and c are the coefficients that will be substituted into the equation. And they are the coefficients of x squared, x, and also the constant value respectively. A will be the coefficient of x squared, b will be the coefficient of x, and the constant value will be c. So there we have it. Ax squared plus bx plus c is the general representation of your quadratic equation from which we extract your a, b, and c, but the actual values will be extracted from the equation that was given, which is of course x squared plus 2x minus 4. So let us begin with the substitution. The values of b will go first, then a will go there, and then the value of c. We can take a second look at it. the value of b is 2. The value of a is 1. And the constant value is negative 4. Now, be mindful that the default coefficient is 1. Therefore, since we have x squared, well, apparently no coefficient, then we are sure that the coefficient in that particular case is 1. We will simplify the resulting expression in order to arrive at the value of x. We just have a negative 2 that will remain as negative 2. We have 2 squared, which is 4. Then we have 4 with 4, that will be 16. But don't forget, negative times negative, that will be positive. We will therefore have a positive 16 right there. We also have 2 times 1, which is 2. So we have negative 2, we will have 2, we will have 4, and then negative times negative is positive. We'll have positive 16. In this step, it is simply just to add 4 to 16, which is going to give 20. There's no doubt that this is just very simple. So 4 plus 16, that's 20, and that's the next step. Everything will be the same as the previous, which will be maybe a little bit of mental gymnastics, or maybe straightforward to some students. We will divide each one of these terms by 2. So we'll divide the negative 2 by 2. And we will divide the 20 by 2, but not quite. Because what we have here is the square root of 20. So in attempting to divide that, let's see what happens. The 2 will be taken under the square root sign. That will happen there. In order to do that, we will have to square it first. Now, in the expression, this has to be 2. If you place this 2 forcibly under the square root sign, then the value will be the square root of 2. Therefore, you will place a value under the square root sign that when you take the square root of it, it is still equal to 2. 4 is the number that should go under the square root sign, as we will see in the long run. We will divide, therefore, 20 by 4. And that will give us 5. So let us say that again. This is no difficulty. Negative 2 divided by 2, negative 1. But when we intend to divide the 20 by 2, the 20 is under the square root sign. Therefore, what we have here is the square root of 20. If we put 2 there, it will be the square root of 20 to be divided by the square root of 2. So in order that we will be correct, we will have to square the 2 before placing it under the square root sign. Now, what we have here is negative 1 plus or minus the square root of 5, and that will be the result. That will be the consequence. Let's go. X is equal to negative 1 plus or minus the square root of 5. The square root of 5 is given as positive or negative 2.236. So what we will have is negative 1 plus 2.236. That will be one of the values. The other value will be negative 1 minus 2.236. This second value will turn out to be negative, and the other will be positive. So one of the values will be positive and the other negative. And notice that we are eliminating the negative value. We don't just get up and eliminate a negative value as we have a mind. We are eliminating it because the value that we are attempting to find is actually a part of the dimensions of a rectangle. And we know that the dimension of a rectangle cannot be negative. It is on this assertion that we are eliminating the negative value. We are eliminating the negative value because the value of x should be a part of the dimension of a rectangle, and the dimensions of a rectangle cannot be negative. So we eliminate that negative value. The value of x is therefore x is equal to 1.236, and that will be, of course, be given its dimension when we get to the rectangle in short order. Now we'll take a second look at what we mean when we say we are placing the 2 under the square root sign, therefore we need to square it. So let us take a second look at that process. Now if we just take negative 2 divided by 2, then that's straightforward. When it pertains to the square root sign, what will actually take place? Our intention is to divide each term by 2. However, anything that is placed under the square root sign will be subject to that operation. Anything that is placed under the square root sign will be subjected to the square root operation. So in order that we will preserve the value of 2 when we place it under the square root sign, because we're actually going to be finding the square root of 2, then we should think then that it should not be 2 that we place there, but the square of 2. So we'll place the square of 2 under the square root sign in order that when we find the square root of that result, it will still be 2. That is why we do it. While under the square root sign, it must have a value of 2, which cannot happen unless we square it. Else, its value will be the square root of 2. So when we place that 2 under the square root sign, its value is the square root of 2, not 2. But we want it to be 2, so we will have to square it. That when we find the square root of it, the square and the square root will have a cancelling effect, and the result will actually be 2. Instead of dividing 20 by 2, we will have to divide 20 by the square of 2, which is 4. And that is responsible for this square root of 5 that we have been using all along. Teachers and instructors, get unlimited access to teaching aids for your virtual classrooms at richardjamesmathematicsresources.com. Also, this is the best place for the hearing impaired to master mathematics as long as you are literate.